So, the first thing we've got to talk about is what angles are going to look like if we put them on the coordinate plane. So like our x, y axis, if we put angles there. So the angles we want to deal with are going to be in what we call standard form. Okay? An angle on the coordinate plane is in standard form when the vertex is on the origin. So your vertex of your angle is right here on the origin. And one ray lies on the positive x-axis. So that's this one right here. Okay? This ray right here is called the initial ray. So this ray right here, the one that's on the positive x-axis, that's the initial ray. And then the other ray of the angle, because an angle is just two rays that share a common endpoint there. The other ray is called the terminal ray. So this one right here would be our terminal ray. Now you can think of these angles a little bit like the hands on the clock, right? So, well, it's perfect right now. Perfect time. So our minute hand right now is at 3 o'clock. That's like positive x-axis. That is our initial ray, right? It's in the perfect spot right now. It won't be maybe by the time we get done talking. But that second hand, as it goes around, forms different angles, right? With that initial ray. Now, in the world of angles on the xy axis, you can either have an angle that goes clockwise or counterclockwise. That may not always be a term that you use a lot in everyday life, but clockwise goes the same direction as a clock, right? So as that second hand goes around, we're talking about going this way, right? The angles on the xy axis are going to go counterclockwise. So that's the opposite direction of a clock. So if you have counterclockwise rotations, that is going to result in positive angles. And clockwise rotations will result in negative angles. How many degrees are we going to have if we spin all the way around? 360. Because if you kind of think about that hand of that clock, right, as it spins around, it makes a circle on the edge. We're really dealing with circles here when we're talking about this. So down here at the bottom of this slide, it asks us to sketch an angle with the given measure in standard position. So if our angle is in standard position, and that's pretty much all we're going to deal with right now, then that means my initial side is right here on the the positive x-axis. So I could go ahead and draw that for every one of these. Okay, and you'll notice right here on this graph that they have given us that that we've got like 90 degrees, 180, 270. If we're going in the counterclockwise rotation, then 0 degrees is right here on the x-axis. And then as we go to the left here, we go that many degrees. So it makes sense that this would be 90 because that makes a 90-degree angle there. And then it adds 90 more, so that's be 180. And here's 90 more, and that's 270. And then if we added 90 more, we'd be back here to 0, but we could also call that 360 degrees. So the quadrants of our coordinate plane, the first quadrant is upper right, second quadrant is right here, third quadrant is over here, fourth quadrant is over here. If you've ever wondered why the quadrants are labeled like that, 1, 2, 3, 4, instead of going 1, 2, 3, 4, or maybe 1, 2, 3, 4, it has to do with the unit circle, because if we do this direction here, here's our first, our second, our third, our fourth. So 75 degrees, which quadrant is it going to be in? It's going to be in that first quadrant, right? Because it is less than 90. It's between 0 degrees would be right here. 90 degrees would be right here. So it is halfway would be 45. So it's going to be a little closer over here like this. So that angle right there would be 75 degrees. And if I wanted to be precise, I'd pass out protractors to you and we could measure it exactly. But I don't want to spend the time doing that necessarily. So we're just going to estimate about 75 degrees. Now, same question for the second one. Which quadrant, just think about it for a second. Don't tell me yet. Which quadrant is negative 160 going to be in? Okay, let's take a vote. Okay, let's take a vote. How many of you think negative 160 is going to be in the first quadrant? Good. What about second quadrant? Third quadrant? Some tentative hands raised. Fourth quadrant? Okay. I'm surprised, and it may just be that some of you are not voting. I'm surprised I did not have anybody say second quadrant. Third quadrant is correct because since this is negative 160, 180 would be right here, right? But we'd be going in this direction, so 160 would be about right here. That'd be a negative 160 degrees. If somebody said it was in the second quadrant, what would be their mistake? What would they probably be thinking? That positive 160 would be in the second quadrant, right? Oh boy, what about number 3? How are we going to do that? Which quadrant do you think? First, second, third, or fourth? Oh boy. Can you even graph it? What is this? This is kind of crazy, right? I don't think Desmos will do this. I do need to look at Desmos and see what it will do, but I'm pretty sure it will not. Okay? All right, Paloma's saying first. All right, let's stand up and try this one, okay? All right, so everybody needs to stand up. We're all going to face the window over there, okay? This is going to be our, imagine that you are you are on the coordinate plane, right? And you have the x-axis is going this way, the y-axis is going this way, right? And you're standing right here, so right here is your terminal side. Now, initial side. Right? If I asked you, everybody give me 75 degrees. Right, do terminal side, and then initial side, and then terminal side. Everybody give me 75 degrees. Right here, this way is 0. This way will be counterclockwise. 75 will be about like that, right? Okay, now everybody give me negative 160. You can switch arms if you need to. It would be about like this. Now, is the human body going to allow us to do 430? It will not. So we can't do 430 with our arms because we have to go around more than once, and it's not going to work. So we know our initial side is going to be right here. All right. So everybody, let's do our terminal side. Everybody, put your hands out. All right. We need to do 430 degrees. Okay. So if we turn this way, that's 90, 180, 270, 360. Okay, so that's a 360 degree angle. We got to go to 430. How much further we got to go? 70 more degrees. So we need to turn about right here. Right? And that would be our 430. So if we draw that down, you can have a seat now. Thank you. If we draw that here, it would look like a 70 degree angle, right? It would look like a 70 degree angle, but if we wanted to mark it we would go all the way around and then back up to that terminal side, and that would be 430 degrees. So when we get crazy angles like that, crazy angles that are bigger than 360, what we can really think about as far as what it looks like whenever we graph it is what we have for coterminal angles. So let's talk a little bit about coterminal angles. Coterminal angles are angles in standard position with the same coterminal side. Okay, so here is an example. 30, 390, and negative 330 are all coterminal angles. So I just copied and pasted the same circle, although I think I made that one a little too big, but it was the same circle. I just didn't shrink it down enough. So these are all the same circle, right? This angle on every one of these circles, this angle right here is 30 degrees. Right? This angle right here is 30 degrees. And that terminal side, which would be this side right here, AC, 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 is in the same position on all three of these pictures. But for the first one, the angle we're looking at is just that normal little 30 degree section, right? On the second one, negative 330, you always have to start right there on the initial side or initial ray, and since it's negative, you would go clockwise 330 degrees like that. 390, you would start right there on the initial ray. You would have to go all the way around for 360 and then back up to the terminal ray. So all three of those, you end up in the same position, but you have different values for the angle. So to find a coterminal angle, as long as you've got a calculator, it's really very easy. You either add or subtract 360 degrees, right? Because if I add or subtract 360 degrees, I'm just taking a full rotation around, right? If you add a full rotation, you're going to end up in the same spot. If you ever watch like snowboarding or skateboarding or something like that on TV, or probably even like, well, figure skating, they always call it like some weird stuff, but you could talk about figure skating that way. Any sport where they spin around, right? Whenever if you watch snowboarding or skateboarding and they spin around twice, what are they going to call it? If they spin around once, what do they call it? A 360. If they spin around twice, what are they going to call it? A 720, right? And then some of them can do like crazy stuff where it's more than that. So what is 3 times 360 times 3? Yeah, 1080. So they spin around 3 times. It's 1080. So, but if you think about a skateboarder doing that, right? So like if you have a skateboarder that's in initial position, right? If they jump up and spin around one full time, right? They end up facing this way. So, like, they end up the same way that they started. If they do a 720, they spin around once and twice, and then they end up the same direction, right? So their landing position is the same, even though one did an extra spin than the other. So that's kind of what's happening here. So this can be asked several different ways, but here is one that I'm probably going to ask on the worksheet quite a bit. Is I'm going to ask you to find 2 coterminal angles, one negative and one positive for each angle measure. Okay, so if I have 50 degrees on the unit circle, or on the coordinate plane, I guess we're not doing unit circle yet. 50 degrees. If I want another angle that is the same as looks the same as 50 degrees, but has been added or subtracted a rotation. If I want negative value for this, I'm going to have to subtract 360. So I'll take 50 degrees and I will subtract 360 degrees. Okay? And that will give me negative 310 degrees. So that would be a coterminal angle. Now, if I wanted to, I could subtract 360 5 times, and that would still also be a coterminal angle. But this says I've only got to do one negative and one positive, so I'm going to leave that alone. If I need a positive, I'm going to do 50 degrees plus 360 degrees, and that will give me 410 degrees. So if I were to graph 50 degrees, negative 310, and 410, they would all really look the same, except for my spinning around the middle would be a little bit different. The terminal side would be at the same place. Okay. Now, it is okay if you want, like if you want to do 50 degrees plus 360 plus 360. There. So 720 plus 50 will give you 770. Okay. It is okay to do that. That is another coterminal angle for this, for 50 degrees. These are infinite. They keep on going. You could add 360 again and again and again and again. It's just going to keep going up and up and up and up by 360, right? Or you could go down and down and down and down by 360. Those are all coterminal angles. Now, it is easier just to do the two closest, right? Because it's wanting the positive and the negative there. So probably 410 and negative 310 are the ones that you would more than likely use. Now, for example 2, it's asking for a positive and a negative coterminal angle. So if you wanted, you could do 480 plus 360, and that would give you 840. Okay, that is a coterminal angle. That works, and it's positive, so that works. But what I would probably do instead, right? 480 is already bigger than 360, right? So I would probably do 480 minus 360, and that would give me 120 degrees. That is a positive angle. If I want to get a negative angle, what am I going to have to do? Okay, minus 720. I have to minus 360 twice, right? So I'd have to do 480 minus 360 minus 360, right? And if I do that, I'll get negative 240, I believe. There. So these are probably your most common answers. But 840 is correct. You could subtract 360 again and get another answer there. So try number 3 and number 4 right now while I need to pass out a tiny piece of string. So try not to lose it whenever I give it to you. We need it on our next part.
Do anything, everything's good.
It's pitch.
Good beat.
Understand where this goes.
Was it cold?
It wasn't too bad. I mean,
Get in the water that day.
No.
Too cold
No.
for that,
Let's see what you guys got for number 3. Who can tell me one of your answers for number 3? Okay, what'd you get, Adriels? 240 is perfect. That's if we add 360. All right, Isaac, how about another one for that one? Negative 480. Those are probably your 2 most common answers for this. Did anybody get anything different? That sounds right. So that would be another possibility there for those. So these 2 first ones are probably your most common answers, but there can be others for that. All right. Let's see. Lily, what about number 4? 495 sounds great. That's if you do 135 plus 360. Rylan, what'd you get for your negative one? Perfect. Negative 225. You just got to do 135 minus 360 there. Did anybody get anything different for those? Negative 5. What? 85. That should probably be correct as well. Right there. So you can do that. You don't have to for these because it only asks for 1 positive, 1 negative, but you can. Okay. Any questions on those? Does that make sense? Okay. All right. So what we have to talk about now is radian measures. And once again, it's not that difficult, and I don't mind teaching it, but I would have left it out and just done degrees on this because we're not going to get far enough with it for you to see the advantage of using radians. But I want you to understand what a radian is. So I have given everybody a tiny piece of string that you hopefully haven't lost yet. If you lost it, you're going to have to borrow your neighbor's. All right, and what you're going to do, I wonder if this is anywhere close to the right size. No. All right, where's mine? Okay, so I'm going to, it's hard for me to do this up here, but I'm going to do the best I can. All right, so you should already have your piece of string that's the same length as your radius. Hopefully it's fairly close. Right there. Cut this right here pretty much anyway. Alright, let's see. Now my circle's not very circular, and it's hard to do, but it's actually easier to do on a flat desk than it is up here. So this is what you're going to do. You're going to take that string that's the length of your radius. We're going to mark off the edge of our circle in increments of the radius. So what you will do is you're going to take that little piece of string and you're going to lay it along the edge of the circle. So it's going to start right there at point B. And it's harder to do up here than it is on your page. I'll try to lay it there. And then you're going to draw a point right here on that.
You want more Christmas decoration?
Clean out your room?
Yeah, no much.
Yeah, kind of.
You know what? I'll take it out.
I can put it up when I put up
I'll take one.
my Christmas tree.
No, you already owe me that. How big do you have? Got a bunch.
I need to put that up. I might laminate it and put it up every year.
We need them to sign it.
Huh?
You need to get them to sign it.
Yeah.
Got one of these things. That's why I said mouth one.
He's been giving them out for a while. Okay, so we're going to put a dot right here. The length, so this right here is our radius. The length of this side, this arc right here is also the length of our radius. Alright? So then we're going to take our string and again, we're going to start at this point. And we're going to lay it along the edge of the circle. Right here. going around the circle. I'm going to quit trying it up here because my circle's terrible. It's like you're going to put a circle, a dot. Measure it out, put another dot. Measure it out, put another dot. And keep going around the circle. So I want you to do that on yours. I'm going to try to do it up here on my screen. Let's see if I can get, that's not the right piece. I think this is it. Okay, and once you have all of your dots, I want you to draw a line from your center to each one of those dots on the edge. So once you have done this, I'm going to draw a line from your I think that I may have cut my strings too long. When you line it up, is the string just a little bit longer than the radius there? Because I think I've cut my strings a little bit too long, because almost all of you are ending up with the same thing here. Most of you guys do not have what I have up here, right? Most of you guys just have 6 pieces that all look pretty much the same, I think. Okay, so if we had done it a little more precisely, we would have all ended up with 6 slices of pie and one tiny little sliver left over like I have up here. Most of you guys ended up with like 6 slivers in general. It is just because this is just to demonstrate what in the world this means. We'll talk about why it should have that extra little sliver there here in a second. So don't worry about it if yours does not look like mine. You don't have to go back and redo it. So this length right here was our radius. This length over here, our arc length, was also our radius. And what you should see is that all of your slices of pie, except for maybe the sliver if you ended up with the sliver, should all be the same size, right? So this angle right here we would call 1 radian. Okay, so that radian is the angle that will go with the arc that has the same length as the radius. Okay, now it does not matter what size your circle is. The circle that I drew up here is a different size than the circle that is on my screen. The circle on my screen is a different size than the circle that's there on your paper. I thought about giving you guys several different size circles, but decided it would take way too long to try to do that if we did. But usually in pre-cal we do like different size circles there also. But what you would see, no matter the size of the circle, if you do it perfectly, you'll get 6 slices and a sliver that are all, their 6 slices are all the same size, and you'll have a little sliver left over. For that. We were maybe not quite perfect, and I am to blame for that because my string was probably a little bit too long. So So let's talk about radians and how we can converge here. So a radian is a unit of an angle measure based on an arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So whenever I'm going to redraw that picture we had from the other page since it's gone. Not the whole thing, but just this little piece right here. So whenever we had that angle right there, this length right here was our radius, and the length of that arc right there was also the radius. So we know there are 360 degrees in a circle, right? So we're pretty familiar with that. But radians are a measure of angles. So that means there's also a set number of radians that have to be in a circle. It should be constant, like 360 degrees. So any ideas on how many radians are supposed to be in 360 degrees? So based on my picture that I had on the last slide, I had 6 slices and a sliver left over. And I told you guys you probably should have that too, but I probably cut my string a little bit too long, right? So it definitely seems like it should be 6 plus a little more, okay? Let's talk about the exact amount that is supposed to be, because it's a very precise number that is supposed to be. We're talking about the edge of the circle, right? What do we call the edge of a circle? The whole thing. Like if we want to know the length of that around the circle, what is that called? Circumference. What is our formula for circumference? Where does note cards go? What is formula for circumference? Two pi times the radius. Now let's think about that a little bit. 2 pi times the radius. That means the radius goes around this many times here. Got it. It's off, but if I draw all these in, right? I've got a radius here, 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 and a radius here. So 1, 2, 3, 4, 5, 6 radii, right, around. Somebody type into your calculator for me, what is 2 pi, if you do it decimal for it. 2831, and we could keep on going, right? That keeps on going, right? So the circumference is 6.2831 times the radius. That is 6 and a little extra, right? So if we had done that precisely, exactly as it should be done, then this little slice right here would be 0.2831 of a radian, right there. What we don't, whenever we're dealing with radians, most of the time we do not use the decimals. It is correct to use the decimals, but we most of the time do not see those written with decimals. They are usually written with the pi still in the answer. So 360 degrees equals 2 pi radians. So every circle has 360 degrees, or if we're using radian measures, it has 2 pi radians. All the way around the circle once is 2 pi. So if all the way around the circle once is 2 pi, what is 180 degrees? It's just pi radians. Okay. And this right here is going to be the key that we have to know to be able to convert back and forth. And you guys are going to be able to use a note card or 2 or 3 on the next test as well. I'm going to give you a new one. All right. So, have any of you guys had chemistry yet? Probably not, right? You take chemistry your junior year, but you have to have math 3. You don't have to have chemistry, right? You can take. They usually encourage you to sometimes, but I don't think you have to. I think if you have physical science, you don't have to have chemistry. You have to have math 3 before you can take chemistry, I believe. Even though it's really just algebra 1 stuff that you need, but you have to be a pretty decent math student in chemistry, so I think that's why that's there. So if you find yourself having to take chemistry, which you may or may not have to, some of you may be still planning on taking that, but you will do a lot of converting units. I think that they call it stoichiometry whenever you're in there. So we have to do a little bit of converting here. You will have a note card and be allowed to use that note card on your test, but you can't use it on your exam. So definitely, I would write this down right here. You might want to put some parentheses around this, just because in the calculator you do need to put the parentheses in there. If I need to convert degrees to radians, let me just tell you a few things that help me remember how to do this without the formula, because I do not like to use the formula. Well, I mean, I am using the formula, but I need to have it memorized and not just blindly using the formula. So, whenever we have radians, whenever we have degrees and we want to change it to radians, we are going to use pi divided by 180. That 180 is our degrees, the pi is our radians. And so if we multiply this by our degrees, and that, that's not a fraction, so we could put it over 1, then we would have degrees up here on top with degrees down here on bottom, and those degrees would cancel out, leaving us with radians. So if you're multiplying by degrees, you need this right here to have the degrees on the bottom. The 180 is the degrees. So if I want to convert 75 degrees to radians, I want to use pi divided by 180 degrees. And I'm going to multiply that by 75 degrees. And that 75 is not a fraction, but I can make it a fraction by putting it over 1. And so what's happening there is like if you take chemistry, you'll learn more about this, but those degrees are canceling each other out so that you now have radians as your answer. So if I multiply this across, now I can in my calculators, if I grab the calculator here, I can do this. I can do pi divided by 180 times 75. And that will give me 1.308996, and that is correct. That is a correct answer. However, you usually do not see these as decimals. Right? There can be cases where maybe they ask for decimals, but most of the time, the answer choices are going to be left where you have like pi still in your answer. So to do this with pi in your answer, to multiply fractions, you just multiply straight across. So you would have 75 pi over 180. Right? And if we're wanting to leave pi in the answer, we would just leave the pi right there in the top, and we would reduce our fraction, 75 over 180. So you can do it by hand if you would like, But on the calculator, if you want to reduce a fraction, you're going to type in 75 divided by 180. What do we hit? Do you guys remember? On the calculator, it is math. Enter, enter. You might want to write that down. And I'll show you how to do it on Desmos too. We're not going to get our computers out right now, but let me show you how to do it on Desmos also. So if I do, let's finish this up first though. 75 divided by 180. Math, enter, enter. It'll reduce that fraction for me. 5 over 12, so I would get 5 pi over 12 radians. If you need to do that on Desmos, because whenever you are doing this at home, you will probably need to use Desmos if you don't have a handheld calculator. So, and your phone calculator might do it, but I would use Desmos instead. So if you do 75 over 180 here, it's going to give you a decimal. But on Desmos, they have this button right here next to the expression. If you hit it, it'll turn it to a fraction and give you 5 over 12. So you just got to hit that button right there next to it, and it turns it to a fraction on Desmos. Oh, wrong thing. Okay, so if I want to do the next one, I've got 270. I would do pi over 180 times 270 degrees. Again, that's not a fraction, so I can put it over 1. Just multiply straight across. So I got 270 pi divided by 180. And then in our calculator, we'll do 270 divided by 180. Math, enter, enter. So 3 over 2. So that would be 3 pi over 2 radians. For the sake of time, I'm going to skip the next one. It's the same thing, just multiply there. Okay. Questions on those? All right. If we need to go back, if we need to go from radians to degrees, okay, notice that the formula looks about the same, but what is different about it? The 180 this time is on top. That pi is your radians, right? The 180 is your degrees. So if you're multiplying by radians over here, you need to have the radians on the bottom. Whatever you're multiplying by, that needs to be on the bottom. So it's 180 over pi for these instead of pi over 180. So to convert pi over 2 radians to degrees, I would have to do 180 degrees over pi times pi over 2. A lot of these you'll be able to do maybe even without the calculator, because what's going to happen when you have that pi in the top of this fraction and pi in the bottom of that fraction, and they're multiplied together? They just cancel each other out. If you have a pi on top and bottom, they cancel each other out. So that gives you 180 divided by 2, and 180 divided by 2 is 90 degrees. So like for example 9, I've got to do 180 over pi times 11 pi over 6. So what should happen most of the time, unless they've given you a strange problem, is the pi's should cancel. And so then you need to multiply straight across. So 180 times 11 is going to be 1980, and the bottom will get 6. And the bottom will get 6. And I think if you do 1980 divided by 6, is it 330? So 330 degrees. Okay, so like if I do the last one here, 180 over pi times 5 pi over 4. The pi's cancel each other out. You'll do 180 times 5, which will be 900. Is that right? Over 4. And 900 divided by 4, 225. Most of the time you will get a whole number on those. There can be cases where you don't, but I think most of the ones you'll see you'll get whole numbers for. Okay. Questions there? All right, you've got one more thing we've got to be able to do. Okay. We have to be able to find coterminal angles in radians as well. Okay. With coterminal angles with degrees, they're much easier because what do we have to do with the degrees if we look for coterminal angles? Like if I've got 25 degrees and I want to know a coterminal angle, I can either add 360 or subtract 360, right? Because that's a whole rotation. The idea is just the same with radians. When you're in radians, you just need to add a full rotation or subtract a full rotation. The difference is that full rotation is not 360 degrees because you're not measuring in degrees. It is 2 pi. So you can add or subtract 2 pi. So the idea is the same as it was whenever we were dealing with the degrees. It's harder to do because you got to deal with the pi's, right? So instructions here are the same as they were whenever we were dealing with the degrees. We need to find for each angle, we need to find 2 coterminal angles, one negative and one positive. So if I have 3 pi, 3 pi, is that more than one rotation or is it less than one rotation? It's more, right? Because 3 pi is bigger than 2 pi, right? So I want to really just do subtracting here. So 3 pi minus 2 pi. What's that going to give us? Pi. So there's one of my answers. Pi radians would be one of my answers. Now if I want to get a negative angle, I'm going to have to subtract 2 pi twice. So if I have 3 pi minus 2 pi minus 2 pi, what am I going to get for that? Negative pi. And if you want to put a 1 there, you can, but it's not necessary. Right, negative 1 pi. Now, I could keep going. It doesn't ask me for others, but I could keep going. I could add 2 pi and get 5 pi. That's a coterminal angle. I could subtract 2 pi 7 times, and I would get a coterminal angle. So those are both coterminal angles here. Okay. Any questions on that? That is not too bad because that doesn't make us deal with a fraction. Let's look at 12. Okay, 12 is more difficult. 2 pi divided by 3. All right, now you can kind of think of this as 2/3 of pi, right? So it is less than 2 pi because it is like 2/3 of a pi. So it is less than 2 pi. So we're looking at something that's like between 0 and 360 if we were thinking in degrees, right? So our best bet here is to add 2 pi and then subtract 2 pi. And that should give us a positive coterminal angle and a negative coterminal angle. So what we can do here, we're starting off with 2 pi over 3. We need to add 2 pi. Now, here's the problem. That is 2 pi over 1. Can I add those together? I cannot because they're not like, they don't have common denominators, right? So if I need common denominators here, I need to multiply the denominator of this fraction by 3. That means I got to multiply the top of that fraction by 3. Okay? So that is going to be the same as doing 2 pi over 3 plus 6 pi over 3. 6 pi over 3 is 2 pi, because if we reduce 6 over 3, it just gives us 2, right? So how do I add fractions? What should I do? Okay, you basically ignore the pi. 2 and 6 will give you 8, but you keep the pi with it, so you got 8 pi. What do I do with the bottom? Nothing, leave it alone. 8 pi over 3. There is my common denominator. You can do it in the calculator, but it is going to give you a decimal, right? So if you do it in the and it won't turn it back. So if you do it in the calculator and try 2 pi over 3, and then you add 2 pi, it is going to give you a decimal. So what you can do is you can check your answer. So I got 2 pi over 3 plus 2 pi gives me 8.377. If I do 8 pi divided by 3, it also gives me that same decimal, so I know I've done it correctly. The calculator won't do it for you, but it will help you check your answer to see if it's right for that, and Desmos won't do it either. There. So that's my positive one. I also have to do 2 pi over 3 minus 2 pi, which we got the same problem we had before. We don't have common denominators. I'd have to multiply by 3 on top and bottom. I will get 2 pi over 3 minus 6 pi over 3. That'll give me negative 4 pi over 3. So there's my negative answer. Okay, here. Okay, questions so far? All right, 13 gives us a negative angle, right? So if we already have a negative, hopefully if we add 2 pi to it, it's going to take us up to the positive. So let's start with that. We got negative 3 pi over 4, and we need to add 2 pi. But just like before, that's 2 pi over 1. Do I have common denominators? I do not. So what do I need that common denominator to be, Rylan? Okay, I just need those denominators to match. So I know the pi's are like crazy, but kind of ignore them. I need those denominators to match. Imagine like you're doing negative 3/4 and positive 2 over 1. What would you use for that denominator? Just a 4 is what you need, right? Because we can just multiply this denominator right here by 4, as long as we also multiply the top by 4, right? So it's going to match whatever the denominator of your equation is. So like over here, I had a 3 and a 1, so I multiplied by 3 right there. So it's always going to be whatever that denominator is for those. So that would give me negative 3 pi over 4, and then I'm adding 8 pi over 4. And to add my fractions, I just add the top. So negative 3 pi plus 8 pi is going to give me 5 pi. And the bottom, keep your denominator the same. So I got 5 pi over 4. And then for my negative one, I would need to do negative 3 pi over 4 minus 2 pi, which I can put that over 1. Same as before, I need those denominators to match, so I'm going to multiply by 4 on top and bottom. I will get negative 3 pi over 4 minus 8 pi over 4. And negative 3 pi minus 8 pi is going to be negative 11 pi. And then 4 stays the same, so negative 11 pi over 4. And again, you could do this more than once. You could add 2 pi a bunch of times or subtract it a bunch of times, but I would just go with the most simple. All right, so you don't really have time to get started, but let me pull up. Your assignment is going to be on Delta Math. And it's going to look just a little different than it sometimes does for you guys. And if you talk to third period, they may say I said to skip the last 5. That is because we did not get far enough. They're going to have to do it tomorrow. So I want you guys to do the whole assignment. Second period didn't get as far as you guys. So let me show you what it will look like. Whenever you do this, it's the 7.1 angle measures. It looks like it has so many to do here. Each one of these first 3 are your normal ones. You're going to just do coterminal angles there. Radians to degrees here, degrees to radians here. The last 5, it did not have coterminal angles for radians. So I had to put my own questions in. So whenever you do these questions, everybody will have the same question. It will not be they'll not be different questions. So like everybody stop for a second and look up here. Let's do this one real quick. Okay, so it says give a coterminal angle for 7 pi over 2 that falls between 0 and 2 pi. Right? 7 pi over 2 is bigger than 2 pi. It might be hard to tell that since it's fractions. But you need to subtract 2 pi. So you will do 7 pi over 2. You will subtract 2 pi. You put over 1 if you want. Isaac, what are we going to do for our common denominator?
Multiply it by 2.
Multiply it by 2. So that gives us 7 pi over 2 minus 4 pi over 2. And that will give me 3 pi over 2. Let's look at how to type it in. Because it's not going to give you a button where you can push for pi. If you type 3 and then do pi, it will turn into a pi for you. And then if you do the slash, it'll make it division. So 3 pi over 2. So for pi, just type pi. To divide, just do the slash. And it'll give you that there. Now, if you miss those, it's not going to let you redo them because it's not got a question bank to pull from because it's ones that I've created. So as long as they are completed, they count. Delta Math is going to say that you did not make a 100, but as long as you've completed everything, you will make a 100. Okay? The first 3 will do normal for that. For those last 5. For the first ones, it'll be like normal where you got to get it right to get the credit. But for those last 5, if you miss it, it won't let you redo it. You just keep on going for that. Yeah, that's fine. Well, normally I would say yeah. Well, it's fine. I got to go take Hunter to the orthodontist, but I'll leave my door open. Okay?
Okay, one confusing thing about that Delta Math is how it's written.
When it says 0 to 2 pi, it just means to get that number closest to 0. Right. So if it's a big number, you want to subtract until you get something there. Another thing you can do there is like if you do 7 pi divided by 2, it gives you 10.9956. 2 pi is like 6.28. So if it's bigger than that, then you know you need to subtract. If it's smaller, like maybe they give you 3 pi over 4, they're probably not going to do that there. But like that one is already between 0 and 2 pi because it's between, it's 2.35. 2 pi is like 6.28 for that. Does that make sense?